Hey there, Urates. In this video here, we're doing exercise 4G. It's to do with total surface area notes. And I like to think of total surface area in this example is to find the total area that you need in order to paint a 3D shape. So here, total surface area is equal to the sum of the areas of all its faces. Okay, so you can think of this diagram here. It's a net diagram of this shape over here. If you can imagine folding them all together, you end up with getting a cube. So how many faces does a cube have? Well, you can see there's 1 at the front, 2 at the back, 3 on the right, 4 on the left, and then 5 on the top, and then 6 on the bottom, right? So there are 6 faces there, and you can already see that's 1, 2, 3, 4, 5, and 6 faces. So if I asked you to paint this cube, you would need to find the area of the front, back, sides, top, and bottom to add them all together to get you your total surface area. So this cube has a total of 6 faces, and therefore the total surface area, which if we were to calculate it, have you noticed that the area, if this is L, length, because it's a cube, it's all the same, length times length will give you the area of 1 face. But you've got 6 of those faces, so you would have done L times L once, plus L times L twice, plus L times L thrice, and then plus L times L, so forth, until you get all 6 areas. So what I'm trying to say is the area of this square here would be L times L, which is L squared, and then this would also be L squared, this would be L squared, L squared, L squared, L squared. So if you want to know your total surface area, well, it's L squared plus L squared plus L squared plus L squared plus, well, there's 1, 2, 3, 4, and you need another 2. There are 6 faces in total, okay? But there must be a shorter way than just doing L squared plus L squared plus L squared. Oh, well, there is. It's just 6 groups of L squares. So you can write it as 6 times L squares, and you would get the total surface area of this cube. Now, your problems that you're going to get may not always be a cube. It could be something else, and you have to adapt to it. But the idea is that you're finding the area of each surface of the 3D shape, hence called total surface area. Let's do some examples here. Let's have a look at example 1. Here you've got a triangular prism, and hopefully you can see that there is a front, which is a triangle. So you know there's a triangle here. There is a back, which is also a triangle. Okay, so we've got 2 triangles so far. So area of front is you've got 2 times area of a triangle. Whereas the back, funny enough, I should have just said triangle. Front and back. So triangle, triangle. And we know that the area of a triangle is half times base times height. Okay, and we'll calculate that soon. And then the area of the sides, let's have a look at the sides. So each side, so the right side and left side, so you can see this is one of the shapes for the sides. And so what we can do is we can find the area of this, and that looks like a rectangle there. But notice that you've got 2 sides, so you've got the right and the left, they're exactly the same shape. So it's actually times 2 of those rectangles. Okay. So that's a 10 by 5. So area of rectangle is length times width. Okay, and we've got 2 of them, so we're going to times it by 2. So length is clearly 10, and the width, so this is length, and then the width of the rectangle is 5 centimeters on that diagonal, and then you times it by 2. So 10 times 5 is 50, 50 times 2 is 100. So we've now got the areas of the 2 sides. Okay, we still haven't figured out the front, which we'll get back to. But then there's the area of the bottom. So the bottom shape is clear, also another rectangle, but with a different length and width. So we can see it's a rectangle, and it is length times width as well, but it is 10 times 6, which gives you 60 squared centimeters. So the only ones that I'm missing at the moment are the 2 triangles at the front and the back. Well, the base clearly, it's half times the base is clearly 6. It could be 4. It actually doesn't matter which one you choose. So 6 times the height, and it's always the vertical perpendicular height to the base. And so therefore it's 6 times 4. So half of 6 is 3, and 3 times 4 is 12 squared centimeters. But since you got 2 of them, you got the front and you got the back, so this is also another 12. So in total, your total surface area is adding them all together, front and back, plus sides, plus bottom. That gives you 12 plus 12, plus 100, plus 60. So in total, that is what? 100 plus 60 is 160, plus 24 is 184 squared centimeters. There you go. That's the total surface area for a triangular prism of this particular scenario, and you can then do the same for this example. Okay, so this one's a bit more odd of a shape, but hopefully you can see that you can use composite shapes and split them up. You can see that you actually got got a triangle, and then you got a rectangle here as well. So if you wanted to find the area of the triangle, we need the height. We know the base already. The base is clearly 1.5 meters. So what's the height? Well, see these dashes here? That implies this is also 1.5 meters. Since this is 1.5 meters, then what is the height of the triangle? Since you know the total is 2.8, well, 2.8 take away 1.5 gives you 1.3 left. So this must be 1.3. Okay, so the height must be 1.3. So putting them all together, let's have a look. Rectangle is clearly length times width is still the same. Technically, it's a square, 1.5 times 1.5, so that should be technically a square. So you're doing 1.5 times 1.5 to find the area of this region. And then the triangle, well, it's half times the base, which is 1.5, and then times the height, which is 1.3. So let's put those two together on your calculator. Go on your calculator. Half, you can type 1 over 2, or you can type 0.5 multiplied to 1.5 times 1.3. And I'm also adding it on with 1.5 times 1.5. So together it's 3.225 squared meters. Okay, so I've done the area of the front. Now the front and the back, if you can picture it, it's actually the same. So the front and back should also be the same. So I would say it is 3.225 squared meters as well. And then now we've got the front and back, we need to do the sides. So if you look at the sides, you can see the side is made up of a rectangle on that diagonal slant and also another rectangle just on the side there. So this is, the slant is clearly got the dashes, so it's 1.5 along the diagonal. And then the length here is 2 meters. So the area of the sides is made up of 2 times 1.5, that's length times width. But then you also got this rectangle down here as well. And that rectangle is also 2 times 1.5. So this works out. That's 2 times 1.5 to find the area of both of those. But remember, you've got the right-hand side, and you also got this side as well. It's the left-hand, so you need to double what those answers are. Have I confused you there? Or you could have done it more separately, but I'm just doing it in a quicker way for you to see. I did the area of the rectangle on the top. I did the area of the rectangle on the bottom. But then since I know the right side and the left side are symmetrical, there must be 2 of them, so I doubled it. Okay? Here we go. Let's answer the question here using our calculator. We'll do 2 times 1.5 plus 2 times 1.5 again. And then don't forget, you end up with 2 of those. So the answer is 12 squared meters. And it looks like I've got them all except for now I'm missing the... Oh, I did the tops. Whoops. I already did the top. So ignore that. And then the bottom, I'm just missing the bottom now. So the bottom is another rectangle. And again, it's a 1.5 by 2, which is really just 3 squared meters. So putting them all together, your total surface area should be 12 plus the 3 plus, and you got 2 of these. So maybe I'll just do 3.225 times 2. Use our calculator, 12 plus 3 plus 3.225 times 2, and you get 21.45. And did it ask to round? No, there you go. That's how you do exercise 4G.